Now it's your turn. Here are 3 exercises to practice everything we've covered in this module. Don't skip this. The only way to internalize Rust is to write it. First exercise is a temperature converter. Implement 2 functions, Celsius to Fahrenheit and Fahrenheit to Celsius. Test your logic in main by converting 100 degrees Celsius and 32 degree Fahrenheit and print the result. Exercise 2, Fibonacci sequence. Write the function Fibonacci and use a loop or an iterator to do not use regression. And this constraint will force you to work with mutable variables, and you should print the first 10 numbers. And exercise 3, documented calculator. Create multiply and divide function. Add the full 3 slashes doc comment, including an example section with executable assertions, and a panic section for the divide function, explaining what happens on division by 0. Run cargo test to verify your doc tests pass. So you can make your research to answer this third exercise. Let's bring it all together. Here are the 4 key takeaways from Module 1. Safety plus speed. Rust guarantees memory safety without garbage collector. This makes it ideal for on-chain logic. No null pointers, no data races, no surprise runtime pauses. You get C-level performance with a safety profile no other system language can match. We learn about the cargo ecosystem. One tool handles everything. The cargo for new, build, run, test, FMT, Clippy, and doc. And we also spoke about immutable. By default, all variables are immutable unless you explicitly use mute. Shadowing allows you to rebind names for data transformations, even changing the type of a value, while keeping each intermediate binding immutable and safe. We also spoke about expressions and testing. Functions return the last expression. No return keyboard needed unless exiting early. The semicolon rule is what distinguishes expressions from statement. And tests are first-class citizens in Rust. So we have the test, and we have the cargo test, and documentation tests are all built into standard toolchain. That's a wrap on Module 1. You've just learned why Rust exists, how its ownership model eliminates memory errors at compile time, how to set up and use the full cargo toolchain, and how to write variables, functions, shadowing, expressions, and tests. This is generally foundational. Everything that comes next, ownership and borrowing, types and traits, error handling, smart contract, builds directly on what you've just learned. If you want to go further right now, work through those 3 exercises. Seriously, do them. Type the code, make mistakes, see what the compiler tells you. The Rust compiler's error messages are famously helpful. They don't just tell you what's wrong, they often tell you how to fix it. Module 2 is coming up next, where we go deep on Rust's type system. Scalar types, compound types, structs, and enums. It's where the real power of the language starts to reveal itself.